Hello and welcome to my demonstration of assignment 3. The objectives of this assignment were to use the Texas Instruments real-time operating system using the TI-RTOS LaunchPad MCU. You can see here in the video feed of the board, we have the TI-RTOS LaunchPad, this is the TI-RTOS TM4C123G, and what we've done here is actually taken the Educational BoosterPack, just kind of slapped it here. So, and the goal of this assignment was to create 4 tasks. So we're going to have an analog to digital converter task, a UART display task, and a switch read task and a heartbeat function. Due to time constraints, I was not able to implement the switch read task, but I was able to implement the heartbeat function, ADC task, and UART task. The heartbeat function is just going to be an idle task on the RTOS, and then let's see, the ADC task is going to be triggered by a timer interrupt, and then the UART task is also going to be synchronized to that timer interrupt. So specifically, I'm going to be using timer 2, and then it's going to be doing a hardware interrupt every millisecond. Every 5th millisecond, the ADC task is going to be started, and then every 10th millisecond, the UART task is going to be started. And then the 15th millisecond, that's when the switch read task is to be performed, but due to time constraints, I was not able to implement this task, so that is not included in my solution. And then all the while, the heartbeat function, which is simply just toggling the LED on PF3 pen, that occurs throughout the entire program. So let's look at the code. So here is my code developed from the MTMin Texas Instruments MTMin example file. I've included the XDC globals header file. This is so that I can get access to my semaphore. We're going to be using 2 semaphores. One is for the analog to digital converter, one is for the UART, and then the timer is going to be posting these semaphores, and the different tasks are going to be ending on those semaphores. Okay, so here's my heartbeat function. This is actually more or less very similar to the heartbeat function provided by Texas Instruments. One thing that's changed is this arg0. I'm no longer using arg0. I just hard-coded in 1000 for the task sleep, and then it's just going to toggle the LED. I created, this is not used, I created this console function, and what this does basically is this is using the UART write. So this is writing characters. I tried to use the printf, built-in printf, but for some reason it did not seem to be compatible with the context switching that occurs and being preempted by other tasks. That printf was just taking way too long to complete. So I'm running at a 9600 baud rate here, and I found that using the UART write, it actually works better with other tasks. One thing I'm going to do is change this to say hello let's just say assignment 3. Okay. Let's see, what else do we have here? Right here, this is the main loop. All of this stuff up here is initializing the UART. But right here, this is actually where we're getting into the main loop, and all this is doing is it's going to wait on its UART semaphore. Once it gets the UART semaphore, it's going to write a prompt. The prompt is simply ADC value. Then I added these curly braces here so that I can hopefully get some garbage collection on my char temp here. This is basically a buffer, and I just wanted it to basically delete the memory allocated for this variable once it leaves the scope. You can just put curly braces anywhere arbitrarily, and it's still going to compile. But once it leaves these curly braces, the idea is I would like it to clear the memory space allocated for this buffer, for this array of 10 characters. The 10 characters have initialized the spaces, and then the default value is 0 all the way down here. And then we're just going to step through this array and take whatever was from our analog digital converter, take that value and take whatever's in the ones place and give it an offset for the ASCII value, and then just put that onto the array as an ASCII value. And then next up, we're going to divide by 10, so you're effectively moving the tens place to the ones place. And so for next time, you're going to be grabbing the ones place, actually the tens place. You're just going to keep doing that all the way until the value is 0. So you're just going to keep dividing and taking the remainder basically with this modulus. So I had to hard code this because I could not use printf. I had to come up with my own way of basically printing out this integer value. Oh, this video is getting kind of long. Okay, I'm going to go quickly over the rest of the code and do a quick demonstration. So yeah, that's my UART. It's just using the UART write, so very robust. Next up is my analog to digital converter task. We're triggering ADC 0, and then we're going to enter into the main loop, and we're not gonna read that. Whatever the ADC just found, we're not gonna actually clear that and get another value until we get that semaphore penned. So this is the main loop. We're gonna stay in here forever. Once we get the OK to start, we're gonna clear the interrupt from the ADC. We're going to get the data, put it into our global variable, and start to grab another value from the ADC. The ADC initialization, we're going to be initializing on port D. We're going to be using that PD3. That is where this analog stick is connected to. The analog stick is just a potentiometer. We're going to be reading ADC values from that. So then down here is my timer task. This is basically going to clear the interrupt from the timer and then increment a count. And then if we're at 5, we're going to start the ADC. If we're at 10, and this is in milliseconds, if we're at 10, we're going to start the UART. If we're at 15, we're just going to reset back to 0. And this is where I would have posted for the switch semaphore to initiate the switch task. Here's the main loop. Not too much going on here. This is not used. We're going to be initializing general, GPIO, UART. This is not used. Down here is my timer initialization, my ADC initialization. I put a default value for debugging purposes for that ADC, and then we're going to start by turning the LED on, and then we're going to start the BIOS. Okay, so let's go ahead and build this. Build project. while that's building, I'm going to connect the board. Board has already been programmed with this assignment 3 code, so it's currently running it right now, but okay, so that built successfully. We're going to start the debugger. We're going to open up a terminal, connect it on COM port 5, 9600 baud rate. This is so we can get access to that UART. And off we go. And as you can see, the LED is blinking on that heartbeat function, and we have some values printing out on the terminal. I think I could probably make this a little bit bigger. Yes. Okay, so as I start to move the analog stick up, you can see the ADC is increasing, and as it comes back down, R0. Can't quite reach 0. That's okay though. Okay, that is my assignment 3. Thank you for watching.